Okay, token drop. And yeah, I was thinking about what to talk about this week, and another one of these party comments came up. If you go to enough parties, I think there's no shortage of content for our token drop here. So, all of you guys out there who are listening to us, all of our listeners, please invite me to your parties so I can get more content here for our token drop. But anyway, so this I went to that party and this guy says, "Hey, the future of AI is not going to be um, prompt engineering; it's going to be context engineering." So, he went on to explain what he meant by that. This one I understood a lot better than the previous comment somebody else made about the, quadratic and the logarithmic. So this one, he said that prompt engineering is about giving instructions to an AI. And context engineering is about giving the entire context to the AI. So if you're asking about a contract, question about the contract, give the contract, all the amendments, your company legal policies, whatever that is pertinent so that the AI can really give you a better answer. And this person felt that really the future is going to be context engineering and not prompt engineering. So that was an interesting comment and wanted to see what you guys think about it.
So yeah, I'll let Sam say because he's been really excited about this topic. Sam, do you want to jump
Yeah.
in?
So yeah, let me start about this. The whole thing about prompt engineering, right? It optimizes the question, right? What is the question we are asking? Whereas context engineering optimizes everything the model seeks, actually. Slight difference, right? So prompt engineering emerged in about 2022 to 23 as a craft of wording instructions to coax the better outputs from the LLMs, right? That was the whole idea. But this whole context engineering which you brought in is a very interesting thing. It's a successor discipline, right? I would call that. So it's the systematic design of the entire input window, which means what? Instructions, retrieve knowledge, like what we talked about, memory, outputs, and state. They're treated as an architecture problem, not as a writing problem, right? I mean, here the prompt is more a writing problem. So the thesis is prompting is UX, context engineering is infrastructure. So the mode is in the prompt, it's the pipeline that feeds it. So that's the high level view of that. Actually.
But
Now, when
Sam,
you,
do
okay,
you also see do you also see the prompt being also including the context as well
yeah,
as a superset that includes the context? And while you can discuss the difference between the two, but oftentimes the prompt and the context are actually fed to the model led by the prompt.
correct, exactly. I mean, I think you are right on the dot. So, in other words, if you look at the broader thing called context engineering, prompt engineering is a portion of it actually, and you can look at it like that. And basically, prompt engineering involves four things, right? One is scope, nature, techniques, and unit of work. The unit of so when you talk about scope, what is it? Wording, structure, examples, etc. The nature of it is mostly stateless, per request, etc. But again, the most interesting thing, unit of work is a screen actually there, right? But when you look at context engineering, it's slightly different because it encompasses prompt engineering and also other things. And the other things are the system prompts, the retrieve documents, the conversation history, the tool call results. So it's bigger, like memory stores, environment state, etc. Right? So basically, I think context engineering is more stateful as opposed to prompt engineering, which is stateless. And again, prompt engineering is per request, whereas context engineering is dynamic. And mostly it's human authored when you say prompt engineering, but whereas when you talk about context engineering, it's machine
But
assembly. So there's
does it,
some differences there.
yeah, I think it matters for us as users of those systems. But as far as the LLM is concerned, does it see a separate prompt and a context, or it just sees a stream of text that it needs to work off of?
Yeah, exactly. The prompt engineering, as you rightly said, is a subset of context engineering, and the system instruction layer, the context engineering subsumes it and adds that to the pipeline, actually, right? So like what you said, that's the whole idea.
It's just a,
Now,
it's just a body of text that is fed to the LLM,
yeah,
and the LLM doesn't know what the prompt is. It doesn't know the system prompt or the user prompt, and it doesn't know how to recognize that from the context, right?
Exactly.
Yeah. It's just
You
one,
said,
yeah.
so I just wanted to understand something Sam said. You said, Sam, that if I heard you correctly, you said that prompts are stateless and contexts are stateful. Is that right?
That's right.
Why are context stateful? Because state means that one query has a relationship to something that some action had some relation to something that happened in the past. Is
So in a way, right? Context engineering, it doesn't involve just prompting is only one portion of it, whereas it has the RAG, the memory hierarchies, the summarization, and any compaction that you do, the relevance ranking, all this, the context routing, all that is part of that context engineering, the token budgeting, all that stuff, which also has statefulness, like memory hierarchies or memories themselves have statefulness, right? I mean, so context engineering is stateful in the nature that it holds all that stuff, and together it is infrastructure engineering in a way. If you really look at it, actually, as opposed to prompt, which is what suggests is stateless completely. Actually, it's just you give it to the LLM, and the LLM answers the prompt. Actually, right? I mean, the
Yeah.
real reason, one of the things that is very interesting is why the prompting plateaued. Right? The reason was everybody, the frontier models became less sensitive to the phrasing aspect of it. So if you phrase it better, there was this whole idea that you could get better things from the LLM, right? But what happened? The tricks stopped mattering after some time, right? So what happened was instruction following improved to the point where clarity beats cleverness, and there was diminishing returns in that actually. So therefore, once instructions are clear, further wordsmithing yields single-digit percentage hit. They didn't see much. So the missing information causes order of magnitude failures also.
Yeah, this was taken to an extreme, right? People would
Yeah.
say, please, Mr. LLM, be nice to me. You you've been outstanding so far. So
good job. Keep it up.
can you go
Pat
out
on the
and
back,
perform this
virtually.
job, right? So I mean, it got to that level, but really, I think what Sam's saying is much more than the platitudes. What really matters is being precise about what you want executed, and then providing the right workload structured the right way, so that the LLM can act on it. While I was saying, all the LLM just sees is a large blob of text or a large, body of tokens. But even so, it begins to recognize the early parts of the tokens, hopefully, and mostly as instructions on, the task that it needs to execute. Having said that, I think, yes, there is some merit in saying those instructions need to be clear, unambiguous, and clearly specified. And because the English language, or any other language for that matter, while us humans can assume context, can make assumptions, and can understand sometimes mostly what is being said, but for the machine to comprehend it at that level, you need to be very, very precise.
So is the engineering portion of this, because I start off by saying context engineering, is the engineering portion of this trying to understand what is the minimum set of context you should give it? Or, because if you throw everything in the LLM prompt, your token costs are just going to go
Not
wacko.
only, not only the token costs will go up, but also, you know, even though last in one of our podcasts we spoke about million token
Yeah.
wide context lengths, even though the LLMs believe that they can process such large context windows, there's something called context rot that start to set in, right? Then unable to focus on the right aspects of that context, and they may miss out. We also spoke about finding that needle in the haystack, or finding those needles in the haystack. So making sure that the LLM picks up all the right instructions sometimes can be challenging when you have very, very long prompts followed by very long context. So that's indeed a challenge. Now, and so to call it prompt engineering is like doing a little bit of a disservice to the scientific rigor with which you do engineering work. So you can say, yes, you got to be precise, specify as precisely as you can, but there's no scientific measure of that precision. There's no scientific method, way of measuring how precise you are, how, complete you are. There's no scientific way of doing so. Having said that, I think there's a framework that came out, I think, a couple of years ago called DISP. So they want to turn prompt uh, building into a programming exercise.
Hmm.
So you can actually write Python code, and then and the DISP framework, you can train certain models called the DISP models, and those DISP models will then, are used by the for generating prompts. I think it's for generating prompts. I could be
Yeah, for
wrong
general
here.
prompt. Yeah, yeah.
I could be wrong here, but yes. So now I think the word is you can actually do programming. You can do Python programming and be as concise, as precise, as complete as you want to be in specifying what you want done, and then use these models to then generate your
But
prompt.
why would you want to do? I don't understand what the benefit of this programming, prompts as programming. Do I understand it like you could have if then statement? If today is Thursday, do this. If today's Friday, do that. Is that kind of the idea?
Exactly. You're basically writing self-improving Python. So you're writing Python code, and then that Python code is processed by the DSP framework. And effectively, you're trying to turn the art of writing prompts in,
Oh, interesting.
into the science of engineering those prompts.
So the actual prompt that's given is generated by this DISP framework.
Yes,
Oh,
correct.
interesting. Oh, interesting.
So we
It's kind
use
of
that. We use the
right.
DSP framework as part of our platform, but
Yep.
that's really what we do. So I think it's a powerful tool. Um, so yeah, so Sam, go ahead. You were saying something when I
So
interrupted.
what I wanted to say was, the prompting plateaued a little bit because of the agentic shift. That was a very important part of it, right? Because when you do multi-turn tool using agents, they can't be driven by single static prompts, right? I mean, so the context evolves there, right? Because it's doing multi-turns actually. And as the context evolves turn by turn, someone has to manage the context actually, right? I mean, and that's where this whole thing from prompt engineering to context engineering came about. And also the longer windows change the problem also. Like for example, now we have 1 million tokens. We have talked about it in several podcasts. The token windows didn't eliminate the curation. They made it harder, right? I mean, more room means more opportunity to fill it with the wrong things, actually. So the failure mode moved from the model misunderstood to the model never saw the information it needed, right? I mean, something like that, or saw too much of the wrong information. So it becomes really important that context engineering, that today is built on many layers. The first, if you see the first layer, the first layer is the instruction layer. There, it's called the prompt engineering layer. So you have system prompts, you have personas, you constraints, output contracts, tool definitions, all that kind of stuff, actually, right? This still matters. It's a stable layer, version control like code. The second layer is the knowledge retrieval layer. There you have the classic RAG, chunk embed, vector set. It's simple, actually, stuff, talking into the context, right? Hybrid retrieval. Then you have graph RAG, but structured retrieval. And then you have finally the agentic retrieval. So these form the knowledge, the layer two, which is the knowledge retrieval layer. The third level becomes the memory, actually. There you have short term, long term, and again, Siddharth talked about it earlier, also episodic versus semantic. So that's a layer three. And the fourth layer talks about state and tools, actually. So tool called results, environment, observations, intermediate artifacts, right? Also in-agent loops, tool outputs, etc., etc. And then finally, the layer five is the compaction of the life cycle, rolling summarization of the history, structured note-taking, things like subagent isolation. So it's a very broader term because it takes into account a lot of things all the way up to layer five. And that final layer is does checkpointing and context handoff between sessions, etc., etc. So if you really look at it, the context engineering is much more evolved because of the agentic multi-term nature, and it's moving in the right direction. Where you have this whole cold corpus, index store, session memory in window. So they are trying to position it in that way so that you move across the axis, like search plus fetch. So that's where you find the whole context engineering moving.
So how do you make this scientific? Because Sajad, you mentioned kind of, prompt wasn't scientific. Um, how do you make context engineering scientific? How do you
Yeah.
know it's you have to, what I'm getting at is you have to find the right amount of context. You don't want to give it too much. It's a Goldilocks thing, right? Not too much, not too little. But how do you know it's too much and how do you know it's too little? How do
And
you
I
use the
think
measure?
that's really where I think I think a measure of success lies, right? How effectively you can construct semantically the right context. So what that also means then is you're offloading some of the intelligence from the LLM into the prep work that happens before the context is given to the LLM. And that's really where some of the symbolic aspects start to come in a neuro-symbolic architecture, right? So now you're building your own understanding of what the question was all about. What is all the content that should be delivered to the LLM as context so that the LLM can be successful in answering that question. So the deeper that part of your pipeline is, the richer that part of your pipeline is in aggregating knowledge, understanding the question, decomposing the question, understanding exactly, precisely what context is needed so that the LLM can precisely answer that question, and providing all the evidence uh, alongside that context in order to help the LLM succeed. I think it's a fair bit of work. That's why they call it context engineering. And in some degree, to some degree, you can call it a science because now the more you comprehend what that question is, the better you're in a position to as accumulate, go out, fetch, accumulate, organize, rank by relevance, rank by importance, um, the context, so that only the most important content is provided to the LLM to turn that content into an answer. So, yeah, so in that sense, it is called engineering, and I would argue it's a discipline. And people are using, in the past, it used to be just naive RAG, right? You knew the answer was in that particular textbook, then you upload that entire textbook, hoping somehow that the LLM will find the correct answer inside the textbook. Then there's a style of this, context engineering which said, hey, why not give the relevant chapter rather than the whole textbook? And then why not give the correct paragraph rather than the whole textbook? And now people have gotten to the point where you can actually cherry pick exactly the entities and the relationships and how they're connected and provide just those precise data points that are needed by the LLM so that that the LLM cannot err on that. So the deeper and the more evolved that engineering of that input window is, uh, the more precise your answers will likely be. But we have also seen, no matter how well you construct that context, every once in a while the LLM can still go off on a tangent and start making the wrong predictions. So post the generation, you still need another pipeline to do the verification, claim by claim, regeneration, and all of those things. But we're not going to go there today. We're speaking about the prep work that is needed to making sure that you do everything you can to help the LLM succeed.
So if you have these multi-stage LLM pipelines, context engineering would apply every single stage, would it not? Not just at the first stage, but wouldn't it apply at the second stage also?
Absolutely. I think that's called the context assembly pipeline, the whole agentic loop, right? So basically, you have the query, which is the task step, which you get the query in. Then you retrieve, right? I mean, using whatever, like dense, sparse, knowledge graph, however you do it. Then Sajjad got to the point of re-ranking plus filter. Then you assemble, which is budget plus position. Then you do the model inference. Then you have the tool calling, which comes down, like, calls to various environments, APIs, through MCP servers, whatever it is. Filter and distill, which summarizes the results. Then compacts the node split memory. Then you have the memory store, where that's the durable memory, which you store on the different types of memory. And then you go back to the retrieve again. That's the whole loop there that's going on, right? I mean, so every aspect of it is, the context is still there.
Yeah,
But
and I could see how you might have different disciplines of context engineering. So just like in a system, let's say an application that has a database and a network and a UI, you would have people knowledgeable in all of those. But they're not the same person necessarily. They'll be different people because each one of them is a discipline in and of itself. It seems like what you're describing, Sam, is, and what I was talking about, because there's these kind of disparate tasks, the understanding the query versus the verification versus, the other stuff you're talking about. Eventually, maybe not right now, but down the road, all of them could be different disciplines akin to what we were talking about.
absolutely, you're on the right track, because the design principles there are very, very simple, right? Like Sujat alluded earlier, that was one of the main things: minimum sufficient context, which means finding the smallest set of high signal tokens that maximizes the likelihood of the desired outcome, right? So you don't want the whole thing, actually. You just want the high signal tokens.
Yeah,
So you do curation over accumulation, right? That's the first thing,
correct.
right? Second is oh, go ahead. So do you have something?
No, complete your thought. I was
Okay.
going
So
to.
that's the first thing. The second is just-in-time work over just-in-case. This is a very common thing to talk about. So retrieve when needed via tools rather than front-loading everything. Because if you front-load everything, you know what happens. The beginning is there, the ending is there, the middle drops off, right? So you want to be loading only what's required. Then you put things deliberately, right? Critical constraints at the top, task immediate data near the bottom. So you have a way of really structuring it. Nothing important in the buried mid-window, because it will drop it. The LLMs drop it, so you don't want it there. Then you have separate pipelines when you're doing it. Like you have instructions, which is the control plane, then the data plane. Never let the data impersonate the instructions, right? I mean, so there are some principles like this, and compact with structure. Then you measure with evals, and finally version and observe. This is okay. You can say, oh, this is whole identical. Yes, at every level, it is part of the context engineering process, actually. And that is the whole idea that Sujat was also talking about. So you can elaborate on that. So that's the whole idea behind it.
Yeah. Yeah. Rather than feed the entire math textbook, right? You had a simple question to answer, which is what is 2 plus 2? And every time you encounter such a question, you don't throw the entire high school algebra textbook at the LLM and say, here's the context, go figure out the answer to the question. So you can be a little bit more discriminating, right? You could say, in this entire textbook, there's a chapter that deals with addition. Let me pick that chapter on addition. And within that chapter on addition, let me get you the rules of addition. And let me find those rules of addition. And there are rules for single digit math, arithmetic. There are rules for multi-digit arithmetic. So this was a question involving multi-digit arithmetic. Let me get those rules. But you might also need the rules for single-digit arithmetic. Let me combine those two rules. So the deeper you go into the subject matter, and the more precisely carve out the context that is needed by the LLM to answer that question, the more precise you can expect the LLM to get. What that then means is then you are now taking on some of the work, right? The easy, lazy thing to do is just throw the entire math book at the LLM and say, you go figure out. Tell me what is 2 plus 2. And the LLM will figure that out eventually. But you could reduce the load by precisely picking out exactly the information the LLM needs to successfully carry out its operation. That is called context engineering. Now, associated with this, there's another concept called loop engineering. Now, people recognize that you create this context, you give it to the LLM, you may still not get the answer you want. So there's an evaluation that takes place after the LLM's answer. Is this answer good enough? If it is good enough, yeah, you're done. But if the answer is not good enough, you want to go back through the loop. You want to go back through the loop and say, hey, did I do something wrong last time? Can I better engineer that context? Can I feed a better context? Maybe I should improve my prompt as well. So, and you can go through that loop. While it's called loop engineering, it sounds exciting. It sounds like scientifically the right thing to do. But each time through that loop, you're burning up tokens. The more iterations of that loop you go through, the more tokens you're burning up. And now the question is, are you really converging to a correct answer, or are you compounding the errors? So you don't know the answer to that. So hopefully the governance mechanisms that you put in place, the checks and verifications that you do, the precision of those mechanisms and the feedback signal that comes out of those mechanisms, and how that feedback signal improves the quality of that loop is a function of how well that loop operates. Otherwise, you could have a loop that's aggregating and compounding errors, and you could have a case of a runaway,
Exactly.
runaway loop. So yes, you could have divergence, you could have convergence, and that's once again, discipline is needed, but it's also you're simply burning more and more tokens. I call it token maxing, and now people are beginning to get very, very concerned about how many tokens they burn, and can you do this more optimally. The more you think of doing this optimally, the more you're driving your architecture towards a neurosymbolic architecture.
Yeah, I think we're almost out of time. Sam, you want to say something else?
So one thing is, if at all from this podcast anybody wants to get away, prompt engineering really means what do I say, right? Context architects really say something different. What does the model need to see, when, and at what cost? That is the difference. So in prompts, you always are worried about what do I have to say to the LLM, right, to get the right output. Whereas in context engineering, it's slightly different. We really think more in terms of what the model needs to see, when, and what cost. And as Sajjad beautifully explained it earlier, that whole loop, right, where it goes, the retrieval happens in a loop, and again you go through the whole cycle actually in a loop, then come back all the way, you distill and you compact the feeds into durable memory, and then again you reiterate and go through the loop until you know that the answer is really in a state where you can digest it, or you can really take it actually, right? So what's important is that the context assembly pipeline, the agent loop, and the per turn data flow actually, which is different. So hopefully it gives some idea about it, but then there are many more things as you dig into the weeds. As you go through it, you have a lot more things in there. But we wanted to I wanted to talk in terms of general what people can understand.
This has been helpful, very interesting episode. I'm going to ask the guy who gave me this this discussion, to ask him to listen to this episode and he give us whatever feedback, and I'll share it if he ever gives me that feedback with you guys. So let's end the recording, and if you guys can hold on for a second, that would be great. Thank you.